Welcome viewers. In this video we'll see the flip-flop conversion. The first one SR flip-flop to JK flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Converting from SR flip-flop to JK flip-flop. We know that flip-flop is a storage element. It will store 1 bit data. The output is depends upon the earlierly available output as well as the input, that is called present state and next state. So the next state is depends upon present state as well as input. So that we have qn plus 1. Qn is the present state, qn plus 1 next state. Right. Now we'll see how to convert SR flip-flop to JK flip-flop. So SR flip-flop, by giving the proper input, we can convert into JK flip-flop. So first we will see the truth table of the JK flip-flop. So what is our requirement? JK flip-flop requirement. So this is the JK flip-flop input, J and K. The output, qn plus 1. Present state, next state. I already told this next state, qn plus 1, depends upon qn as well as 2 inputs. So totally 3 inputs, J, K, qn will decide qn plus 1. So 3 variables, 2 to the power 3, 8 combinations are available. 0, 0, 0, 0, 0, 1, 0, 1, 0 like that. Otherwise 0, 0, both are 0, 0, qn plus 1 may be 0 or 1. Similarly 0, 1, the qn may be 0 or 1. 1, 0, 2 combination, 1, 1 like that, 8 combination. So first both J and K both are 0 in the 2 possibilities. Qn may be 0 or Qn may be 1. So both the inputs are 0 means there is no change in the next state. Present state 0 means next state also 0. 1 means 1. There is no change. This is called a no change state. 0, 1. 0, 1 means there are 2 possibilities. 0, 1. Here is 0, 1. 1 is the K input. Actually this is set reset. S is similar to set, K is similar to reset. So the reset input is 1 means it will reset the output. Reset means 0. 0 means 0 maintain, 1 means it will make it to 0. It will reset the output. Whatever may be the input, whatever may be the present state, the next state should be 0. Then 1, 0, 2 possibilities, 1, 0, 0, 1, 0, 1. 1 is the J input. J means set. It will set the output as 1. Whatever may be the present state, next state is 1. If both are 1, 2 possibilities, 1, 1, 0 or 1, 1, 1. Both are 1 mean toggle. The present state 0 mean next state 1. Present state 1 mean next state 0. So this is the nature of the JK flip-flop. Both are 0, no change. Both are 1, toggle. 0 to 1, 1 to 0. 0, 1 means reset to 0. 1, 0 means set the output 1. So this is 4 possibilities. Now we need to decide what is the input to the SR flip-flop, because we are going to convert SR flip-flop into JK flip-flop. So the SR flip-flop we need to give the input based on the JK flip-flop. So this is our requirement, 0, 0, 0, 1. Then how to decide the input to the SR flip-flop based on the excitation table of SR flip-flop. What is excitation table? Output, from the output we can decide the input. Truth table means input from output. Excitation table means output, present state, next state. From that we can see what is the input required. For example, present state is 0, next state also 0 means what is the input we need to give? That is 0x. If we give 0x, x means or maybe 0 or 1. That is 0, 0 or 0, 1 means the present state and next state is same. 0, 1. Present state is 0, next state should be 1 mean we need to give 1, 0. Then 1, 0. Present state is 1, next state should be 0 means 0, 1. What we need to give SR input is 0, 1. Then 1, 1. Present state is 1, next state also 1. We need to maintain the 1, 1 means we need to give the input as x0. x0 means x may be 0 or 1. 0, 0 or 0, 1 will give 1, 1. So based on this excitation table, now we need to fill this SR input. See, 0, 0 means 0x. So where is 0, 0, 0, 0 is available. So 0x. Here also 0, 0. So 0x. So by giving 0x input, we'll get the property of the JK input. Similarly 0, 1 means 1, 0. Where is 0, 1? Here 0, 1. So 1, 0. Here 0, 1. That is 1, 0. Then 1, 0 means 0, 1. Where is 1, 0? Here 1, 0. 0, 1. Here 1, 0. 0, 1. Then 1, 1. Where is 1, 1? Here 1, 1. Means x0. Here also 1, 1. x0. Now all are completed. So from the excitation table of SR flip-flop, we decided the SR input. So by giving this input to the SR flip-flop, we can get the output of this JK flip-flop. Right? This is our output required. For that, what is the input needed? SR flip-flop, that is decided from the SR flip-flop excitation table. Output for that, what is the input? By using excitation table, the SR input is now completed. So by using the K map, we need to find the expression for S as well as R. So that is the input given to the flip-flop. Right. Now we'll see the expression for S and R by using the K map. So this is the K map available for S. What is the three inputs? J, K, Q, N. J is available vertically, K and N is available, Q, N is available horizontally. J one variable, two possibilities, 0, 1. That means J bar J. K, Q, N, four possibilities, 0, 0, 0, 1, 1, 0, 1, 1. We know that there is an interchange between third and fourth column. 0, 0, 0, 1, 1, 0 available in fourth column, 1, 1 available in third column. So K bar, Q, N bar. K bar, Q, N, K, Q, N, K, Q, N bar. Now these inputs are filled from the truth table, 0x00, 1x01. So continuous, what is available in the truth table, that can be, if we can fill it there. So there are these two ones are available. So we can combine these two ones. Right? So while combining these two one, what is, we need to refer the corresponding row. Here J is available. Corresponding column, first column and fourth column. K bar, Q, N bar. K, Q, N bar. So K bar, K got cancelled. Only Q, N bar is available commonly in first column and fourth column. So the expression for S is J, Q, N bar. Right. Similarly, the logical expression for R. Same thing we repeated. Here these two ones are combined together. These values are we framed from the truth table. So these ones are combined. So while combining these two ones, we have to refer the corresponding first row and second row. So J bar J got cancelled. So corresponding column, third column, what we have, J, K into Qn. So expression for R equal to K into Qn. Now we got the expression for S as well as R. S equal to J Qn bar. R equal to K into Qn. So by using that, we can draw the logic diagram. Logic diagram for converting SR flip-flop into JK flip-flop. Right. So this is a SR flip-flop. This only we are going to convert into JK flip-flop. S input, R input, clock input, Qn output, Qn bar complement of the output. Right. What is the expression for JS is J into Qn bar. R is K into Qn. Right. Now we'll see the expression is available. S is nothing but J into Qn bar. So we need one AND gate here. One input is J, another input is Qn bar. Right? This is Qn bar. So from Qn bar is connected to AND gate. And another input is R, K into Qn. Here we need one more AND gate. K is one input, another input is Qn. From here Qn is connected. Right? So J into Qn bar is S, K into Qn is R, K into Qn R. So by giving this flip-flop, by giving this input, this SR flip-flop will produce the output of JK flip-flop, because here we identify the expression for J and K from the truth table. Right. Now we converted SR flip-flop into JK flip-flop. Now some descriptions available. We'll see that. In JK flip-flop, J and K are given as the external input to S and R is the S and R in the flip-flop. So this J and K is the external input. Normal input is S and R. Here both S and R are outputs of combinational circuit. So this S and R produce the output. This JK is the external input. The current state is denoted by Qn plus 1 in the next state to be found where J and K inputs are applied. So while applying J and K input, we can get the Qn and Qn plus 1, two states, present state and next state. So in this video, we discuss how to convert SR flip-flop into JK flip-flop. First, we discuss the truth table of JK flip-flop. From the truth table, we can decide what is the SR input, SR flip-flop input. That is decided from SR flip-flop excitation table. After filling the SR input by using K map, we got the expression for S as well as R. Then that S and R is given to the SR flip-flop using AND gate, so that this SR flip-flop is converted into JK flip-flop. SR input is the internal input, but is given through the JK input as a external input by the logic gates, AND gate. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the flip-flop conversion JK flip-flop to SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, JK flip-flop to SR flip-flop. We know that flip-flop is a storage element. It will store 1 bit data. The output depends upon the previous output as well as input. That is called input, present state, next state. So the next state depends upon present state output as well as input. That is the nature of the flip-flop. So we are going to convert JK flip-flop into SR flip-flop. We know that S means set means 1. R means reset means 0. So JK flip-flop is converted into SR flip-flop. So first we will see the SR flip-flop, details about the SR flip-flop. Then we will decide what is the JK input. Based on the SR flip-flop truth table, we need to decide the JK flip-flop input, so that JK will be converted into SR. Right. So this is the conversion table, truth table of the, first we will see the truth table of the SR flip-flop. So I already told that S and R is the input. This is present state, Qn. Qn plus 1 is the next state. So this next state depends upon the present state output as well as the inputs. So there are 3 things will decide the Qn plus 1, S, R and Qn. So 3 variables, 2 to the power 3, 8 combinations are available, 0, 0, 0, 1, 1, 0, 1, 1. Again, otherwise 0, 0, 0, 0, 1, 0, 1, 0, 1, right. Otherwise 0, 0, 0, 1, 1, 0, 1, 1. Again 0, 0, 0, 1, 1, 0, 1, 1. In all the cases, this is 0. This present state is 0, this is present state is 1. So the totally 8 combinations. So first we will see the 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1 with present state is 0. If both input S and R is 0, means no change in the next state. Both are same. 0, 1 means reset. Reset is 1. Reset means 0. It will make the output is 0. 1, 0. 1 means set. Set means it will set the output as 1. 0 means it will convert into 1. 1, 1 means that is invalid. For SR flip-flop, this 1, 1 input is invalid. That is rectified in the JK flip-flop. Right. So both are 0 means no change. R input is 1 means reset 0. S input is 1 means set the output as 1, set 1. Both are 1 means invalid. Again, same thing repeated if the present state is 1. 0, 0 means no change. 1 means present state 1 means next state also 1. 0, 1. 0 means reset. Reset means it will reset the output is 0. If 1 means changed to 0. 1, 0. 1, 0 means set. Already 1 is there, so it will maintain 1. 1, 1 means invalid. Right. So this is the truth table of the SR flip-flop, right? Both are same, both are 0 means no change. R input 1 means reset 0. S input 1 means set 1. 1 1 means invalid. Now for this present state and next state, we need to decide what is the input to the JK flip-flop. By giving the proper input to the JK flip-flop based on the truth table, the JK flip-flop can be converted into SR flip-flop, right? So the present state 0, next state also 0 means what is the input? That can be decided from the excitation table of the JK flip-flop. What is excitation table? Truth table means from input we are checking the output. Excitation table means from output. For 0, present state is 0, next state also 0 means what is the input? From output we are checking the input, that is called excitation table. So this is the excitation table of the JK flip-flop. Present state 0, next state also 0 means we need to give 0, J is 0, K is X. X means it may be 0 or maybe 1, right? 0, 1. Present state is 0, next state should be 1. 0 should be converted into 1 means we need to give the input as 1x. 1, 0. Present state is 1, next state should be 0 means x1. Present state and next state both are 1 means x0, right? 0x, x0, 1x, x1. So the JK flip-flop, the separate video available, the explanation of the JK flip-flop, right? Now based on this, we need to fill this JK flip-flop input. See this, 0, 0. Means 0, 0 means 0x, 0x. Here also 0, 0, so 0x, right? Then 0, 1. 0, 1 means 1x. We need to give 1x. So this is invalid, so it is taken as don't care condition. Both are x. 1, 1. Here 1, 1 is there. 1, 1 means x0. 1, 0. 1, 0 means x1. 1, 1 is x0. Last one is invalid. So it is taken as don't care condition. So from the excitation table, we filled the input for JK inputs. So these JK inputs are filled according to the SR, so that JK flip-flop will be converted into SR, right? So I will explain again. 0, 1 means 1x. See here, 0, 1 means 1x. Like that we filled all the columns. Now we need to find the logical expression for J and K based on this value using the Karnaugh map. Using the K map, we need to find the logical expression for J and K based on this value. Now we'll see the logical expression we'll find from the K map. So this is the K map for J input. So there are three input, S, R, Qn. S are two inputs, Qn present state. S is available vertically. R and Q1 available horizontally. S is one variable, two possibilities, 0, 1, S bar, S. R, Qn, two variables, four possibilities, 2 to the power 2, four possibilities, 0, 0, 0, 1, 1, 0, 1, 1. There is an interchange between third and fourth column, right? 0, 0 means R bar, Qn bar, R bar, Qn, R, Qn, R, Qn bar, right? So from the truth table, these values are filled. This is nothing but, we know the min term, 0, 1, 2, 3, 4, 5, 6, 7. So these tables are filled. So only 1, 1 is there. But we can use this don't care condition for grouping. So these four cells are grouped together. These four cells are grouped together means we need to correspondingly verify the second row. What is available second row? Yes. So similarly we need to verify all these four columns. But all these four columns cancelled. R bar, Q bar cancelled by R, Qn. R bar, Qn cancelled by R, Qn. All are cancelled. Only S is there. So J equal to S. So by giving the J input is yes. We need to give J input as yes. So that JK flip-flop can be converted into SR. Right. Similarly for K, same tabular column, S, R, N, three variables. Right. Here only one is available. So these four cells are grouped together. We cannot group these 0. While grouping these 4 cells, we need to verify corresponding first row and second row. First row S bar, second row S got cancelled. Similarly, third column and fourth column. Third column R Qn, fourth column R Qn bar. So this Qn bar got cancelled. Only R is available commonly. So that K equal to R. Right? Now we got the logical expression for J and K. J is S, K equal to R. Now we can implement this logical expression with the logic diagram. We can go for the logic diagram. So this is the JK flip-flop that we need to convert into SR flip-flop. J input, K input, clock input, output Qn, complement of output Qn bar. Now we decided J equal to S, K equal to R. From the truth table, from the K map we decided that J equal to S. J is given as S input. K equal to R. K is given as R. Right? So where the expression is very simple. Very simple expression. We got J is S, K is R. Right. Now we'll see the description. So that this JK flip-flop now converted into SR flip-flop. S and R will be external inputs to the JK flip-flop. J and K will be output of the combinational circuit. So this S and R is the external input. J and K is the internal input. So J and K value has to be acquired in terms of S, R and Qn. For every combination, the equivalent Qn plus 1 output are found. The output for 4 combination S equal to R equal to 1 is not acceptable. Therefore, these outputs are considered as invalid and J and K values are taken as don't care condition. Right? So what is this? This J and K is expressed in terms of SR. For every next stage of flip-flop Qn plus 1, we calculated from the truth table. If S equal to R equal to 1 means invalid, right? Indeterminate in SR flip-flop. That is eliminated in JK flip-flop. So that this is not acceptable, that is invalid, that is taken as a don't care condition, X. Based on that, we found the truth table and we calculated the logical expression. So in this video, we discuss about how to convert JK flip-flop into SR flip-flop. First, we discuss the SR flip-flop truth table. For that, we need to decide the JK flip-flop input from the excitation table of JK flip-flop. Then the expression for J and K is found from the Karnaugh map, K map. That logical expression is implemented with the JK flip-flop. So that JK flip-flop will be converted into SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the flip-flop conversion SR flip-flop to D flip-flop. Converting from SR flip-flop to D flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Conversion of SR flip-flop to D flip-flop. We know that flip-flop is the storage element. It will be able to store 1 bit data. So here we need to convert SR to D flip-flop. SR means set reset. We know that it's a very basic type of flip-flop. So we are going to convert SR flip-flop into D flip-flop. So first we need to see what is the D flip-flop input and output. That is truth table. So flip-flop, we know that the output we have 2 stages, present state, next state. Qn is the present state, Qn plus 1 is the next state. So the next state of output is depends upon present state output as well as input. Output is depends upon input as well as the present state. So these two will decide the next state of output. So the D input, we'll see the D input. There are 2, now we have two inputs, D as well as Qn. So 4 combination, 0, 0, 0, 1, 1, 0, 1, 1. D may be 0, Q1 also 0. D 0, Qn may be 1. D1, Q1 will be 0, D is also 1, Q1 also 1. Right. What is the nature of the D flip-flop? what is the D input, that will be reflected as a next state of the flip-flop. D0 means Qn plus 1 also 0. D1 means Qn plus also 1. It will not bother about the present state. The next state is purely based on the D input. It will follow the D input. Input what we are giving, that is appear as the output of the flip-flop, that is next stage. Right, that is the nature of the D flip-flop. Now we need to decide what is the input to the SR flip-flop, because SR flip-flop we are going to convert into D flip-flop. By giving the proper input of SR flip-flop, that will convert it into D flip-flop. That is 0 0. Present state is 0, next state is also 0, mean what is the input to the SR flip-flop. Similarly 1 0 0 1 1 1, we need to give the proper input. So that can be done by the excitation table. Excitation table of the SR flip-flop. By checking the excitation table we can refer. Excitation table, what is the excitation table? That is output, present state and next state. We are deciding what is the input. Truth table means from input we are checking the output. From output we are deciding the input is called a excitation table. For example, present state is 0, next state also 0, mean what is the input we need to give. Similarly, present state is 0, next state is 1, mean what is the input required. That is the excitation table. So this is the SR flip-flop. 0 0, present state, next state 0, mean we need to give the input as 0x. 0, S is 0, R is X. R X means 0 or 1. It may be 0 or 1. Suppose 0 1 we need. Present state 0, next state 1, means the input what we need to give 1 0. S is 1, R is 0. 1 0. Present state is 1 and next state is 0, mean what we need to give 0 1. S is 0, R is 1. Suppose both are 1. Present state also 1 and next state also 1, means what we need, means we need to give x into x and 0. S input is x, R input is 0. So based on this truth table we can fill this SR input. 0 0, both present state and next state 0 0, mean what is the input? 0x. 1 0, 1 0 mean we need 0 1. 0 1, 0 1 means 1 0. 1 1 means x0, right? So excitation table we filled the input for SR flip-flop. Now we need to find the logical expression for S and R by using the K-map. By using K-map we need to find the expression for S and R. Now we'll see the K-map. What is the K-map available for finding the expression of S and R? So this is the K-map available. First we will find the S for expression for S. So two inputs D and Qn. D and Qn. From that we can find the expression for S. D available vertically, Qn available horizontally. D one variable, two possibilities 0 1, D bar D. Qn one variable, two possibilities 0 1, Qn bar Qn. So from the truth table we filled these columns 0 0 1 x. So we can group these two cells. So correspondingly what is available in the row D? The corresponding column Qn bar Q1. So got cancelled. We need to refer first column and second column. Both are cancelled. Second row what is available? D. So the S input is D. So this is the K-map for R. In this, these two cells are combined together. These two are 0. So correspondingly we refer the first row. First row is D bar. First column and second column Qn bar Qn. So got cancelled. So R input is D bar. From the truth table we frame the K-map. From the K-map we got the expression for S and R. S is D, R is D bar. Complement D, D bar. Right. So by using this we can go for the logic diagram. We can design the logic diagram for this conversion of SR flip-flop to D flip-flop. So this is the SR flip-flop. S input, R input and clock. Qn output, Qn bar complement of the output. So what is the S input? S input is nothing but D. We need to give S equal to D. So S is given with D. And R is nothing but D bar. So by connecting one NOT gate, D is converted into D bar, that is given to R. So S is connected with D and R is connected with D bar, so that this SR flip flop will perform the operation of the D flip flop, because we are used this expression. Now we'll see the description is available. As shown in the diagram, actual input of flip flops are S and R, where D is the external input. So for this flip flop, S and R is the internal input, but external input is D. We design the D accordingly. We design the expression for S and R accordingly we given. The four combinations of S and R in terms of D and Qn, conversion table, logic diagram and K-map are shown in the diagram. So in this video we discuss converting from SR flip flop to D flip flop. First we discuss the D flip flop. What is the nature of the D flip flop? For that, what is the input need to given to SR flip flop? For that we refer the XR flip flop excitation table. From the excitation table, we fill the SR flip flop inputs based on the D flip flop. Then by using K-map, the expression for S and R is identified from the K-map, and that is implemented with the logic diagram by using the SR flip flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the flip-flop conversion D flip-flop to SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic. Flip-flop conversion D type to SR type. We know that flip-flop is a storage element. It will able to store 1-bit data. The output, two stages available: present state, next state. The next state output is depends upon the present state as well as the input. Input, present state will decide the next state. So that is given here. Qn is the present state, Qn plus 1 next state. So this is the basic about the flip-flop. D flip-flop and SR flip-flop. SR flip-flop, we know S means set the output, set means 1. R means reset, reset means 0. Now we'll see the conversion table, D flip-flop to SR flip-flop. So the D flip-flop going to convert it into SR flip-flop. So first we'll see the truth table of the SR flip-flop. What is the nature of the SR flip-flop? S input, R input, the output present state Qn, next state Qn plus 1. So Qn plus 1 based on Qn as well as S and R. So three variables will decide the output Qn plus 1. Three variable mean 8 combinations. Otherwise 0 0, 0 1, 1 0, 1 1. For 0 0 Qn may be 0 1. For 0 1 Qn may be 0 or 1. Like that we have 8 combinations are available. Right. What is the nature of the SR flip-flop? If both S and R is 0, both inputs are 0 means no change in the present state and next state. Present state 0 means next state also 0. Present state 1 means next state also 1. No change. No change in the present state and next state. 0 1. 0 1 is nothing but R. R means reset. Reset means the output is reset. The next state is reset to 0. 0 means 0 is maintained, 1 means 0 is converted into 0, right? So if the R input is 1, S input is 0 means the output will be reset, that is 0. 1 0, 1 0 means 1 is nothing but S, set in, set. So it will set the output as 1, set means output is 1. 0 means converted into 1, 1 means maintain as it is. If both are 1, S and R values are 1 means it is a invalid, indeterminate. Right, that is not defined in the SR flip-flop, that is defined in the JK flip-flop, right? So both are 0 means no change in the present state and next state. 0 1 means output is reset, next state is reset to 0. 1 0 means next state is set to 1. Both are 1 1 means invalid, right? So this is our requirement, this SR flip-flop. So we need to give the D flip-flop input in such a way that we need to get the status like that, 0 0, 1 1, 0 0, like that, right? So based on this we need to decide the input of D flip-flop. by giving the proper input to the D flip-flop, the D flip-flop can be converted into SR flip-flop, right? So that we need a excitation table. What is excitation table for the D flip-flop? From the output, we need to decide what is the input. For present state is 0, next state is 0 mean what is the input to the D flip-flop. 0, 1 mean what is the input. Truth table means from input we are checking the output. Excitation table means from output we are checking what is the input needed. Right. So this is the excitation table. 0, 0 means D input is 0, 0, 1 means 1, 1, 0 means 0, 1, 1 means 1. What is there by excitation table? This D input and next state of output both are same. What we are giving the D input, that will be reflected as the next state, whatever may be the present state. That is the nature of the D flip-flop. The input what we are applied, that is available as the output, right? So 0 means 0, 1 means 1, both are same. Whatever may be, it will not bother about present state. Next state is nothing but what the input we applied. So these two are same. So this can be now based on this we can fill this value. 0, 0, 0, 0 means 0, 0, 0 means 0, right? Then 0, 1 means 1. 0, 1 means present state 0, next state 1 means we need to give D input is 1. Where it is available? Here is it. 0, 1 means we need to give 1. 1, 0 means 0. It is available. 1, 0 means 0, right? 0, 0 means 0. 0, 0 means 0. 0, 1 means 1. 1, 0 means 0. And another is 1, 1. This 1, 1 means 1. Here also 1, 1 means 1. So from this excitation table, we filled the D input. These two are don't care, invalid, so it is taken as don't care condition, X, treated as X, right? I think you are able to understand. If present state 1, next state 0 means D input is 0. This present state 1, next state in 0 means D input is 0. Based on this, we filled this value. Now we need to find the logical expression for D input. We need by using the Karnaugh map. Then that can be implemented with the logic gates, with the logic diagram. Now we'll see the K map to find the expression for D input. So this is the K map available. It's a 3 variable K map. The input is S, R and Qn. 2 inputs and present state. That will decide the next state. So the input is S, R, Qn. S is single variable, 2 possibilities. S bar, S, 0, 1. R into R, Qn, 2 variables, 4 possibilities. R bar, Qn bar, 0, 0. R bar, Qn, 0, 1. R, Qn, 1, 1. R, Qn bar, 1, 0. Right? So this 8 column we can fill from the truth table. We know that this is 0, 1, 2, 3, 4, 5, 6, 7. So the what is available in the truth table can be filled here, right? So these 3 are zeros available, these 3 ones available, and these 2 are don't care condition. So there are 2 groups are available. These 4 cells are grouped together and these 2 cells are grouped together, right? If these 4 cells are grouped together, we have to refer the corresponding second row. Second row is S. What is the column? First column, second column, third column, fourth column, we have to refer. So while referring these 4 columns, all are cancelled. R bar, Qn bar cancelled by R Qn. R bar, Qn cancelled by R Qn bar. All are cancelled. Only this S is available. So while grouping these 2 cells, we have to refer the corresponding first row and second row. S, S bar got cancelled. What is available in the second column is as it is R bar, Qn. Right? So the D input is equal to S plus R bar Qn. So by giving this input to the D flip-flop, that will be converted into the SR flip-flop. Right. Now we'll see the logic diagram. So the logic diagram is available. So this is the D flip-flop that can be converted into SR flip-flop. The D input is a clock input, Qn output, Qn bar complement of output. We need to decide what is the D input. What is the D input? S plus R bar Qn. So this addition is there. So we have one OR gate. One input is S. Another input is R bar Qn. Right. So here in the one more here R bar Qn we need one AND gate. One input is R. After the NOT gate it become R bar. Then Qn is connected. Output Qn is connected. So after this AND gate we got R bar Qn, that is added with the S. So S plus R bar Qn given to the D flip-flop input. So that this D flip-flop will be converted into SR flip-flop. Right. Now some description available. We'll see the description. D is the actual input of the flip-flop where S and R are the external inputs. That is given. This is the D input. Normally D is the internal input. S and R is the external input. So that is given here. Then there are 8 possible combinations are obtained from the external input S, R and Qn. We discussed the truth table that we have 8 combinations we obtained. Then since the combination S equal to R equal to 1 is unacceptable, invalid. So that is treated as the DQN bar taken as don't care condition. We taken as don't care condition, then we executed the truth table. So in this video we discuss how to convert D flip-flop into SR flip-flop. First we discuss the SR flip-flop truth table. Based on that we decided the D input. What is the D input given? From the excitation table of D flip-flop. Then D input logical expression is obtained from the Karnaugh map. That logical expression is implemented with the logic diagram using D flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the flip-flop conversion JK flip-flop to T flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. JK flip-flop to T flip-flop. We know that flip-flop is a storage element. It will store 1 bit data. The output, there's 2 stages available. Present state, next state. So the next state output is depends upon present state output as well as input. So input, present state output will decide the next state output. That is the nature of the flip-flop. Now we need to convert JK flip-flop into T flip-flop. I will see the conversion table. First we will see the what is the requirement of the T flip-flop. The truth table of the T flip-flop. So the input, T input is available. This Qn is the present state output. Qn plus 1 next state output. I already told next state output is depends upon present output as well as input. So input, present state output, 2 variables. So 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. If t equal to 0, present state 0 means next state also 0. If t equal to 0, present state 1 means next state also 1. So for t equal to 0 means no change in the present state and next state. Same is following. If t is 1 means present state output is 0 means next state output is 1. Toggle. The output will toggle if the t is 1. Similarly, t is 1 means present state 1 means next state is 0. So it is very simple. T is 0. T input is 0 means no change in present state and next state. 0, 0, 1, 1. If t equal to 1 means toggle. 0 means 1, 1 means 0. So that is the nature of the T flip-flop. So based on this present state and next state, we need to give the JK flip-flop input because we are going to convert JK flip-flop into T flip-flop. Right. So the JK flip-flop input is given such a way that it should satisfy this truth table. Then how to decide if 0, 0 means what is the input to the JK flip-flop? That can be done by the excitation table of JK flip-flop. What is excitation table? From output we are deciding the input. Truth table means from input what is the output we are checking. Here the output Qn plus 1. 0, 0 means what is the input we need to give. 0, 1 means what is the input we need to give. That is the excitation table. So this is the excitation table of the JK flip-flop, Qn plus 1 output. For that we are checking two inputs J and K. Two variable, four combinations are available 0 0 0 1 1 0 1 1. JK flip-flop separate video available. Explanation of JK flip-flop separate video available. So for this 0 0 mean the JK input should be 0x. The J is 0, K is x. X mean either 0 or 1. 0 1. Present state is 0, next state should be 1 means the input what we need to give 1x. 1 0 mean x1. Both are 1 1 mean x0. So this is the excitation table of the JK flip-flop. So by using this we can fill this JK input. So this is the truth table of the T flip-flop. Here we need 0 to 0. Present state 0, next state also 0 mean what is the JK input that can refer from excitation 0x. Right. 1 1 means x0. 0 1 means 1x. 1 0 mean x1. Right. So from the excitation table the JK inputs are now filled. So this is the T flip-flop truth table. For this truth table the JK flip-flop inputs are decided from the excitation table. Now we need to find the expression, logical expression for J and K using the K map. Then that can be implemented with the logic diagram. Now we'll see the logical expression for J and K using the Karnaugh map, K map. So this is the K map available. This is for J. First we'll see the J. There are two inputs T, Qn. Right? T and Qn. From that we can find the expression for J. This is 4 variable. These two boxes are not needed. The T is placed in the vertical. Qn is available in horizontal. T 1 variable, 2 possibilities 0 1. T bar T. Qn also 1 variable, 2 possibilities 0 1, Qn bar or Qn. So these 4 values are from the truth table we can fill 0x 1x. Right. So we are combining these two cells. While combining we can use the don't care condition. So while combining these two cells we have to refer the corresponding row. It is available T. Corresponding column, first column and second column. Qn bar Qn both are cancelled, only T. So J input is T. Similarly the truth table for K, the K map for K output. Same thing Q, T, Qn. Here these two cells are combined together. Same thing only. Here 1x, here x1. So while referring the corresponding row 1, that is T. Corresponding column Qn bar Qn both got cancelled, only T. So J input is T, K input also T. Now we can see the logic diagram, how to convert the JK flip-flop into T flip-flop. So this is the JK flip-flop available. JK, two inputs, clock pulse. This is the output Qn, complement of the output Qn bar. So from the K map we decided, we got the expression J equal to T, K equal to T. So the T input is given to J. The same T is given to K also. So that this JK flip-flop will be converted into T flip-flop. Right. So very simple. J and K inputs are T. Some small description available. In this type of conversion, J and K are the actual inputs of the flip-flop, where K is considered as the external input. Right. So J and K is the actual inputs. This say T is the external input. This is not K. This T is considered as external input. We are giving T as the external input. Actual input is J and K. Then 4 combinations are created by T, Qn, J and K that are expressed in terms of T and Qn. The truth table we discussed 4 combinations 0 0 0 1 1 0 1 1. From that we decided the output, what is the input for JK flip-flop from the excitation table. So that is given. Then it is expressed, that is J and K is expressed in terms of T. From that we draw the logic diagram. So in this video we discuss how to convert JK flip-flop into T flip-flop. First we decided the T flip-flop truth table. For that we decided what is the JK input. Then J and K logical expressions are obtained from the K map, and that is implemented with the logic diagram. JK flip-flop converted into T flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the flip-flop conversion JK flip-flop to D flip-flop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic JK flip-flop to D flip-flop. We know that flip-flop is the storage element. It will be able to store the 1-bit data. The output having two stages, present state and next state. Next state output is depends upon present state output as well as input. So input, present state output will decide the next state output. So this is about the flip-flop. Now we'll see how to convert JK flip-flop into D flip-flop. Now we'll see the conversion table. So we are going to convert into D flip-flop. First we'll see the details about D flip-flop. So this is the input, D input. Qn is the present state of output. Qn plus 1 next state of output. So this next state of output depends upon present state output as well as input. So these two will decide the Qn plus 1. So D input, Qn, based on that we will get the Qn plus 1. D, Qn, two variables, so 4 combinations are available. 0, 0, 0, 1, 1, 0, 1, 1. For this D is 0, in that the Qn may be 0 or 1. D1, in that Qn may be 0 or 1. For that we need to see the output, next state output Qn plus 1. If D equal to 0, Qn is 0 means Qn plus 1 also 0. If D equal to 0, Qn is 1 means Qn plus 1 0. So here 0 means 0. So the nature of D flip-flop is what is the input of the D flip-flop, that will be reflected as the next stage of output. It will not bother about the present stage output. So D input is equal to Qn plus 1 next stage output. Right. So the D0 means Qn plus 0. 0 means 0. D1 means Qn plus also 1. D1 means Qn plus also 1. Right. So the D input will be reflected in the Qn plus 1 without bothering about the present state of output. D input is the present next state output of the D flip-flop. That is the nature. So what is the input we are giving, that is available as a output. If 0 is given, 0 will be available. If 1 is given as a flip-flop input, the next state output also 1. That is the nature. So based on this, we need to decide the JK flip-flop input, because we are going to convert JK into D flip-flop. Now we discuss the D flip-flop nature. So based on this, we need to decide what is the input given to the JK flip-flop, so that JK flip-flop will be converted into D flip-flop. Then how to find this? From the excitation table of JK flip-flop, we can fill these details. So what is the excitation table? From the output, we are checking what is the input. Truth table means from the input, we are verifying what is the output. Here the output, present state and next state, 0, 0 means what is the JK input we need to give. That is called a excitation table. 0, 1, present state is 0, next state is 1 mean what is the input we need to give. So this is the JK flip-flop excitation table. The explanation of the JK flip-flop available separate video. Link is given in the description box. 0, 0, present state is 0, next state also 0 mean we need to give the JK input is 0, x. J is 0, K is x. X means maybe 0 or 1, right? So 0, 0 means 0x. See here 0, 0 means we need to give the JK input as 0x. Then 0, 1. Present state is 0, next state should be 1. What is the input? 1x. Here available. 0, 1 means 1x is given. Then 1, 0 means x1. 1, 0 means x1. 1, 1 means x0. 1, 1 means x0. So from the excitation table of JK flip-flop, the JK inputs are now filled. Right? So D flip-flop, based on that JK inputs are given. So JK flip-flop will be converted into D flip-flop. Now we need to find the logical expression for J and K. Then that can be implemented with the logic diagram. Now we will use the K map to find the logical expression for J and K. Now we'll see the K map. So this K map available. This is for J, this is for K. So the two inputs D and Qn. D input, present stage of output. D one variable, two possibilities 0, 1, D bar, D. Q1 also one variable, two possibilities 0, 1, Qn bar, Qn. These four values are filled from the truth table 0x, 1x, what we discuss as a JK input. So these two variables are combined together. What is available corresponding row? D. Second row is D. What is available corresponding column? First column and second column Qn bar, Qn. So got cancelled. Only D. So the J input is nothing but D. Similarly we have for K. This is for K. Same thing. Input D, Qn. D bar, Qn bar, Qn. Here from the truth table it is filled Jx1, x0. Now these two variables are combined together. 1 is there. So corresponding what is available first row? D bar. What is available in column? Qn bar, Qn. Both got cancelled. Only D bar. So J equal to D, K equal to D bar. We need to implement this logical expression in the logic diagram. Now we'll see the logic diagram. So this is the logic diagram. JK flip-flop available. J input, K input, Qn output, Qn bar complement of output. So what is the input to the J flip-flop? J is D. K is nothing but D bar. So D is directly connected to J. By using one NOT gate, it is obtained D bar that is connected to K. This is clock pulse. So D is given to J, D bar is given to K. So that this JK flip-flop will be converted into D flip-flop. Some of the descriptions available. We'll see the description. In this type of flip-flop conversion, J and K are the actual inputs, where D is the external input of the flip-flop. So this JK flip-flop, J and K is the internal input. For that we are giving D as a external input. The four combinations of the flip-flop will be done by using D and Qn. And in terms of this, J and K are expressed. Right? We analyze the four combination with D and Qn 0, 0, 0, 1, 1, 0, 1. From that we discuss K and K. J is nothing but J equal to D, K equal to D bar. That is given, expressed in terms of J and K. So in this video we discuss about the conversion of JK flip-flop into D flip-flop. First we discuss the D flip-flop truth table. Based on that we decided the JK flip-flop input from the JK flip-flop excitation table. Then that from the table we got the expression for J and K using K map. That expression is implemented with the logic diagram. So that JK flip-flop is converted into D flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the flip-flop conversion D flip-flop to JK flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, flip-flop conversion from D type to JK type. We know that flip-flop is a storage element. It will store 1-bit data. The flip-flop, the output, two stages available, present state, next state. So the next state output is depends upon present state output as well as the input. So input, present state output will decide the next state output. This is the details about the flip-flop. Now we'll see the how to convert D flip-flop into JK flip-flop. First you will see the conversion table. So we are going to convert into D flip-flop into JK flip-flop. So first you will see the truth table of the JK flip-flop. J and K, two inputs available. Output, two stages, present state, next state. Present state Qn, next state Qn plus 1. So this Qn plus 1 depends upon our next state output is depends upon present output Qn as well as the two inputs. So J, K and Qn will decide the Qn plus 1. J, K, Qn, 3 variable, there are 8 possibilities are available. 2 to the power 3, 8 possibilities. That is 0, 0. First 0, 0, 0, 1, 1, 0, 1, 1. For J and K 0, 0, here 2 possibilities, 0, 1. 0, 1, 2 possibilities, 1, 0, 1. 1, 0, 2 possibilities, 0, 1, 1, 1, like that. Right? So here both are 0, 2 possibilities, 0, 1. Right. So J0, K0 and Qn also 0 means the next state is same, no change. If J and K both are 0, 0 means no change in the next state of output. 0 means 0, 1 means 1, no change. Present state and next state both are same. If 0, 0, 1, J is 0, K equal to 1 means K means it is a, normally it is called SR flip-flop. S means set, R means reset. If the reset input is 1 means it will reset the output. Reset means 0. Reset means it is reset to 0. For 0, 1, the present state is 0, next state also 0. 1 means it will make it to 0. Right? So 0, 1, 1 is J input, J means reset, it will reset the output to 0. 1, 0, suppose if it is 1, 0 means, this is 1 means J input, set. It will set the output as 1. Whatever may be, it will set the output as 1. If both are 1, J also 1, K also 1, toggle. Present state 0 means next state 1. Present state 1 means next state 0. So this is the nature of the JK flip-flop. Both the inputs are 0 means no change in the present state and next state. 0, 1 means reset the output to 0. 1, 0 means set the output to 1. 1, 1 means toggle 0 to 1, 1 to 0. Right. Now this is the truth table. Based on that we need to decide the D input, D flip-flop input. By giving the proper D flip-flop input, the D flip-flop will be converted into JK flip-flop. Right. For 0, 0 means what is the input? 1, 1. Present state is 1, next state is 1 means what is the input we need to decide. That can be done by the excitation table of D flip-flop. What is excitation table? Output. From the output we are checking the input. Truth table means from input we are checking what is the output. J input, K input, Qn, what is the output? That is truth table. The excitation table means the output. For example, present state 0, next state also 0 means what is the D input? We are checking the input, that is excitation table. So Qn, Qn plus 1. 2 variable, 4 combination. 0, 0, 0, 1, 1, 0, 1, 1. For present state is 0, next state also 0 means D input is 0. 0, 1 means 1. 1, 0 means 0. 1, 1 means 1. What is the nature of the D flip-flop? The input what we are giving, it will be reflected as a next state of flip-flop. It will not bother about the present state. The input what we are giving is available as a output. That is the nature of the flip-flop. So D0 means Qn also 0. Qn plus 1 means D also 1. So both are same. Right? It will not bother about present state. So that this D flip-flop is also used as a register. Register or counters we are using D flip-flop. Counters mean what the input we are giving, that same input will be available in the registers also. Right? So D input is reflected as a next state of output without bother about the present state of output. Both are same. So based on that we can fill this table. D input. 0, 0. If we want 0, 0. What is the value? D should be 0. See. 0, 0 means D is 0. Here also one 0, 0 is there. D is 0. 0, 1 means 1. Here 0, 1 is there. 1. Here also 0, 1 is there. 1. 1, 0 means 0. Here 1, 0 means 0. 1, 0 means 0. 1, 1 means 1. Here 1, 1 is there. 1. Here one more 1, 1, 1. So now we decided the D input based on the excitation table. Now we need to find the logical expression for D input using the Karnaugh map. By using Carnap map, we need to find logical expression for D input, and that should be implemented with the logic diagram. Now based on this, we will see the Carnap map to find the logical expression for the D. So this is the K map available. The three inputs J, K, Qn. J is available vertically. K and Qn available horizontally. Right. So this J, one variable, two possibilities, 0, 1, J bar, J. K, Qn, two variable, four possibilities, 0, 0, 0, 1, 1, 1, 1, 0. We know that there is an interchange between third and fourth column. 0, 0 means K bar, Qn bar. 0, 1 means K bar, Qn. 1, 1 means K, Qn. 1, 0 means K, Qn bar. Now all these values are filled from the table, what we discussed, conversion table. We know that this is 0, 1, 2, 3, 4, 5, 6, 7. So these 8 variables are filled together. So there are 4 ones are available. So these 2 ones are combined together and these 2 ones are combined together, right and left. So these 2 ones while combining, we have to refer the corresponding first row and second row. J bar, J got cancelled. Then corresponding second column, K bar, Qn. So one input is K bar, Qn. While referring these 2 ones is available in the second row. So it is J. This J is there. Then corresponding first column and last column. First column K bar, Qn bar. Last column K, Qn bar. So this K bar got cancelled. Qn bar available commonly. So that Qn bar. J, Qn bar is another input. So the D equal to J, Qn bar plus K bar, Qn. Now we need to implement this logical expression in the logic diagram so that we can convert D flip-flop into JK flip-flop. Now we'll see the logic diagram. So this is the logic diagram available. It's a D flip-flop. D input, clock input, Qn output, Qn bar, complement of output. Right. What is the D input? We need to give J, Qn bar plus K bar, Qn. So here we need one AND gate. Here we need one AND gate and both are added by one OR gate. So here one OR gate is there, 2 AND gates are available. Right. For the first AND gate, J input is given. One more input is Qn bar. This Qn bar is available here. So Qn bar and J is given. Another AND gate, Qn. Qn is available here. Qn is connected and K bar. K bar is needed. So K input with NOT gate is connected. So it becomes K bar. So K bar, Qn, here J, Qn bar. So both are added together and given to the D flip-flop. So that this D flip-flop will be converted into JK flip-flop. Now we'll see some small description is available. In this type flip-flop conversion, J and K are the external inputs of the flip-flop where D is the actual input. So in the D flip-flop we need to give the D input, that is the actual input, but we are giving externally J and K as the input as a external input so that it will convert into JK flip-flop. The 8 combination can make by using the J, K and Qn that's shown in the table. The what we discussed conversion table, J, K, Qn is the 3 variables. So based on that 8 combinations are available. Thus D stated in terms of J, K and Qn. That is, what is D stated? D stated in terms of J, K and Qn. J, Qn bar plus K bar, Qn. Right. So in this video we discuss how to convert D flip-flop into JK flip-flop. First we discuss the JK flip-flop truth table. Based on that we decided the D flip-flop input from the D flip-flop excitation table. Then we calculated the logical expression for D input, then that is implemented with the logic diagram using D flip-flop. So that D flip-flop is converted into JK flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.